Hello students, this is a video on the quant topic test available on the Bodhee Prep Android app. The idea of these tests is once you've gone through basic concepts of a topic, you want to check them in an exam format, and that is where these tests come into play. Every test is followed by a video which gives you the solutions and a brief analysis of what would have been a good attempt in an exam like this. There are more than 200 such topic tests available on the Bodhee Prep app. The app link is in the description below, so make sure you download the app and make the most of these tests. This video is on the topic probability. This is test number 4 that we're discussing. Overall, this test was easy to moderate, and about 7 out of 10 questions in 20 minutes would give you a 95% time. If you look at the questions, the first one says 4 persons are asked the same question by an interviewer. If each has independent probability of 1 by 6 of answering the question. So probability of answering the question is 1 by 6 independently. Therefore, probability of not answering the question will be 1 minus 1 by 6, which is 5 by 6. The probability that at least one answers correctly. Now, probability that at least one answers correctly for 4 people will be 1 minus probability that no one answers. When we remove no one answers correctly, what is remaining is at least one will answer, because out of 4 people, either 0, 1, 2, 3 or 4 people will give the right answer. We are asked to find out at least one. So if from 1 we remove no one answers the questions, we will get the probability of at least one person answering. This becomes 1 minus. Now the first person should not answer, can do it in 5 by 6 probability. The second person again will get the wrong answer with a probability of 5 by 6. So will the third, so will the fourth. And therefore the probability that at least one answers correctly will be 1 minus 5 by 6 raised to power 4. This is a standard question, and therefore should be done in about a minute and a half. It's a basic number, and you're just looking to get the expression, no calculation either. A person draws a card from a pack of 52, replaces it and shuffles the pack. He continues doing it till he draws a spade. The probability that he'll fail exactly the first 2 times. The probability that he will fail exactly the first 2 times. So first try he fails. Second try again he fails. Third try he cannot fail, because he'll stop once he gets a spades, and he has to fail exactly twice. So third time he has to pass. Pass means drawing a spade. There are 13 cards of spade out of a total of 52. So the first failure will happen in 39 out of 52 ways. 39 cards apart from spade, one of them is taken out of 52. It is replaced. The next again in 39 by 52 ways. Finally, 13 upon 52 ways. This is 3 by 4. This is 3 by 4. This is 1 by 4. And therefore, overall, 9 by 64 is the probability that he will fail exactly the first 2 times, and never after that. In the third try, he will get the spade that he wants. Again, this is the kind of question that you've done earlier. Therefore, I am saying easy, about a minute and a half to solve. A committee of 5 is to be chosen from a group of 9. The probability is that a certain married couple will either serve together or not at all. So out of 9 people, suppose there are 7 singles and 1 couple. The total number of ways in which people can be selected will be 9C5. Favorable cases are either the couple is there, couple selected, or not selected. Now, if we select the couple, we already have 2 people for us. We need 5. So out of these 7, we need to choose 3 people, plus the couple, which can be chosen in one way. This, or the couple is not selected. If the couple is not selected, 2 people go away, 7 people are remaining. We need 5 people out of these. So favorable cases will be 7C3 plus 7C5. Total case will be 9C5. So 7C3 becomes 7 into 6 into 5 upon 3 into 2 into 1. This is 35. 7 into 6 upon 2. This is 21. So favorable cases 56. Total cases 9C5. 9 into 8 into 7 into 6 upon 4321. 4 twos are 8, 3 threes are 9. And therefore probability will be 56 by 3 into 7 into 6. 7 eights are 56. 2 fours are 8, 2 threes are 6, and therefore 4 by 9. Option 3 becomes my answer. At best, I'll call this a moderate question because we'll have to look at two cases, about 2 minutes to solve. An integer x is chosen from the first 50 positive integers. So total possibilities for x is anything from 1 to 50 positive integers. That is, total 50 cases are possible. Probability that x plus 100 by x is greater than 50. Now we can make a quadratic out of here. Or multiply this by x rather. X is positive is known. So x square plus 100 upon x is greater than 50. X square plus 100 minus 50x is greater than 0. We can cross multiply because x is positive. So from here we'll get the range for x being greater than 0. But what I'm doing is, rather than doing this, I'll just put the value and check, because the number is manageable. If x is equal to 1, let this be fx. This will be greater than 50. 1 plus 100. If x is equal to 2, 2 plus 50, fx will be greater than 50. If x is equal to 3, now 100 upon 3 is 33 plus 3 will be 36. So fx will be less than 50. As the divisor keeps on increasing, this value will keep on falling. It will fall till 25, when we'll get 25 plus 100 upon 20 or something like that. Beyond that, again, if we make x large, we will still get this more than 50. For example, if I put x as 47, we'll have 47 plus 100 upon 47. Now 100 upon 47 is less than 3. So 47 plus less than 3 is less than 50. If you look at 48, 48 will be 48 plus 100 upon 48. 100 upon 48 is just more than 2. So 48 plus 2 will be again greater than 50. Similarly, for x is equal to 49, 49 plus 2 point something will be greater than 50. And if x is equal to 50, again we'll have 50 plus 100 by 50 will be 52, which is greater than 50. So as we can say, these three cases here and these two cases here are the favorable cases. For anything in between, x plus 1 by 100 by x will not be greater than 50. So favorable case is 5, total case is 50, probability required is 1 by 10, option 3. Since the numbers were manageable, I put the value and checked. The pattern was visible, or at least with a few numbers, it kind of was visible that it will be the extreme values, and therefore I think calculation becomes easier. We don't have to solve the quadratic. But in any case, about 2 minutes to solve. The probability of India winning a test match against West Indies is 1 by 2. So probability of India winning is 1 by 2, which means probability of India losing will also be 1 by 2. Assuming independent from match to match, the probability that in a 5-match series, India's second win occurs in the third test match. So first test, second test, third test. The third test, India has to win, and this has to be the second win. So it could be loss, win, loss, or win, loss, win. In both cases, case 1, case 2, this will be India's second win. This can happen in first match, can be lost by Indian with a probability of. Second match, 1 with a probability of half. Third match, 1 with a probability of half. So case 1, probability is 1 by 8. Similarly, for case 2, we have a similar probability. Either case 1 will happen or case 2 will happen. Therefore, total probability becomes 1 by 8 plus 1 by 8, which is 1 by 4. Option 1 becomes my answer. Again, maybe since two cases are to be formed, so I'm saying moderate. Because of this half, the value becomes easy to solve. About a minute and a half to solve. 7 white balls and 3 black balls are randomly placed in a row. The probability that no 2 black balls are adjacent. 7 white, 1, 2, 3, 4, 5, 6, 7, and 3 black. The total ways of arranging them will be total, we'll have 10 balls. 10 factorial. Out of this, 7 are same and 3 are same. The probability no two balls are adjacent. Favorable cases is no two black balls are adjacent. So we arrange the 7 white balls in 7 in one way. 1, 2, 3, 4, 5, 6, 7, 8. 8 gaps are created. We choose any one of 3 of these 8 gaps and put the black ball there. Through this, we can be sure that there will be at least one white ball between two black balls. This can be done in 8 factorial upon 3 factorial, 5 factorial. And therefore, the probability becomes, should not have divided here, this is total. 8 factorial upon 3 factorial, 5 factorial upon 10 factorial, 7 factorial, 3 factorial. 3 factorial, 3 factorial cancel. 8 factorial, 5 factorial, 7 factorial, 10 factorial. 8 factorial divided by 10 factorial will give us 9 into 10. 5 and 7 will give us 6 into 7. 6 into 7 upon 90, 15, and therefore required probability comes out to 7 by 15. Option, I think basic arrangement concepts are used. So concept-wise moderate. Calculation also I think moderate, so about 2 to 2.5 minutes to solve. If 3 distinct numbers are chosen randomly from the first 100 natural numbers, total number of ways of doing this is 100 C3. So then the probability that all 3 of them are divisible by 2 and 3, both 2 and 3. Number divisible by 2 and 3 actually are numbers divisible by 6. Amongst the first 100, these numbers are 6, 12, 18 and so on till 96. There are 16 such numbers. So favorable cases will be that we choose 3 out of these 16 numbers, and therefore the probability becomes favorable cases 16 C3 upon 100 C3. This will be 16 into 15 into 14 upon 3 to 1. 100 into 99 into 98 upon 3 to 1. This becomes 16 into 15 into 14 upon 100 into 99 into 98. 14 sevens are 98, 4, 25, 3, 5, 3, 33. So we have 4 at the top. 7 into 33 into 35. 7 into 33 will be 210, 21. 231 into 5. 5 1 5, 5 15, 5 1, 1155. So this becomes 4 upon 1155, which is option number D. From the options, we can see that the denominator is large. We had matched the numerator, so only this is a large enough denominator. Could have been marked. Again, I think this is an easy question. 116 C3 upon 100 C3 is all that needed to do. So not more than a minute and a half to solve. One Indian and 4 American men and their wives are to be seated randomly around a circular table. Then the conditional probability that the Indian man is seated adjacent to his wife, given that each American man is seated adjacent to his wife. Now, Indian man adjacent to his wife and American men adjacent to their wives. If we are making this case, what happens is we get 5 pairs, 1 pair here, 4 pairs here. 5 pairs around a circle can be arranged in 4 factorial ways. And each pair, the people then can be interchanged in 2 ways. There are 5 pairs, so 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5. Therefore, the number of favorable cases will be 4 factorial into 2 raised to power 5. So here the Indian pair is together, the American pairs are together. Total number of ways will be, when the American pairs are together, Indians could be anywhere. So we have 4 pairs of Americans plus 1 Indian male plus 1 Indian female. These 6 people to be arranged in a circle, which can be done in 5 factorial ways. For each of these pair, husband and wife can be interchanged. And therefore, total number of ways of arranging people such that the American men are seated together, American pairs are seated together will be 5 factorial into 2 raised to power 4. And therefore, the overall number will be favorable cases 4 factorial into 2 raised to power 5 upon total number of cases 5 factorial upon 2 raised to power 4. 4 upon 5 factorial will be 1 by 5. 2 and 2 cancel, and therefore overall probability becomes 2 by 5 option 3. Again, the idea of conditional probability is there. I am trying to do it without getting into the formula, and therefore I'm saying maybe difficult questions, especially if we try to write the entire formula. But solving time should not be very high, about 2.5 to 3 minutes to solve. An experiment has 10 equally likely outcomes. Let A and B be two non-empty events of the experiment. A consists of 4 outcomes, the number of outcomes that B must have so that A and B are independent. If A and B are independent, we write P A intersection B is equal to P of A into P of B. The probability of A and B happening together is probability of A into probability of B. If this happens, they are independent. Now, probability of A intersection B will be number of elements in A intersection B divided by total number of outcomes, which is 10. Probability of A has 4 outcomes. So 4 out of total outcomes. Probability of B is number of elements in B upon 10. Number of outcomes. 10 and 10 cancel. And therefore 10 times number of elements in A intersection B will be 4 times number of elements in B. Divided by 2, 5 times number of elements in A intersection B will be 2 times number of elements in B. Since left hand side is a multiple of 5, right hand side also has to be a multiple of 5. 2 is not a multiple of 5, therefore number of elements in B has to be a multiple of 5. Therefore it could be 5 or 10. Cannot be more than 10 because total outcomes are 10. Depending on the value of A intersection B. So if this is 5, A intersection will be 1. One outcome will be common. This is 10. 5, 2 5s are 10. This is 5, two values will be common. This is 10, 4 values will be common. So number of outcomes of A, B could be 5 or 10 because it has to be a multiple of 5. Again, not a very common sort of a question that you come across. So I'm saying difficult question. Solving time may not be high, but definitely concept-wise difficult. The coin of diameter D is tossed, diameter, which lands on a square tile of side A, probability that the coin will fall completely within the tile. If you look at the square tile having side A, the center of the coin can fall anywhere in this area, and therefore the total area for which is available is A square. If the coin has to be entirely inside the tile, the center of the coin has to be at least d by 2 away from the edges. Therefore, for the center of the coin, if we find out a favorable area that so that the entire coin lies in the tile, this has to be at least d by 2. This has to be d by 2. Similarly, this is d by 2. This is d by 2. Distance of the center from the edge should be at least half of the diameter. So I can say that the favorable area will again be a square with side. This entire side was A minus d by 2 minus d by 2. So we will get a square with side A minus d. So the favorable area where the center can land is A minus d square. The total area is A square, and therefore the required probability becomes A minus d square upon A square. Geometrical probability, the concept. I think this question again you would have come across while practicing. Otherwise, overall moderate level of difficulty, about maybe a minute and a half to two solve. If we look at the overall test, let's said about 7 questions in 20 minutes is what we're looking for. My 7 questions will be 1, 2, 3, 4, 5, 6, 7. Which are these? Definitely doing this. I've done multiple questions like this earlier. This also, I think, is a basic question which we've done earlier. A person fails in the first 2-3 attempts and then wins. So we multiply probability. So definitely doing this. This I think was a simple question of making cases, therefore doing this as well. Put value and check, even that got us the answer. So attempting this one as well. This also, I think there are two simple cases. The probability is half. So doing this question will not be difficult. Arrangement question. Therefore, definitely doing this as well. This question, I think, was one of the easiest questions. 3 out of 100 numbers, 3 out of 16 numbers divide. This, I think, was a good question. There is conditional probability, circular table involved. Pairs are to be made. So not counting this as an attempt question. This also, I think, is something that is not a very common question. Therefore, not counting this as an attempt question. This one, again, if you've seen this question, becomes a lot easier. May not be able to do it directly in the exam. So not counting this as an attempt question, but 1 to 7 will give us our 7 questions net correct for a 95 percentile in about 20 minutes.